General Atomics Aeronautical Systems has taken another step in demonstrating how advanced unmanned aircraft can integrate directed energy weapons. The MQ-20 Avenger, a jet-powered drone designed and built in the United States, was recently shown in a new concept configuration featuring a high-energy laser mounted directly in its nose section. This concept was presented at a major defense conference and reflects how U.S. defense technology is evolving toward highly capable, autonomous systems that combine stealth, endurance, and precision engagement capabilities in one platform. Company representatives explained that the design is a conceptual rendering meant to illustrate current research and technological progress, not a depiction of an existing operational aircraft. However, the decision to publicly display such a design is significant. It signals that the development of airworthy laser systems has moved beyond theory and is now a core part of America's next-generation unmanned combat aircraft strategy. The Avenger, already proven as a flexible and fast platform for testing emerging defense systems, provides an ideal airframe for exploring these advancements. The integration of a high-energy laser into the Avenger's nose replaces its usual sensor dome with a rotating, turret-like structure. This allows the system to aim in multiple directions without changing the aircraft's course, offering both offensive and defensive versatility. Lasers of this type are designed for precision engagement using concentrated light energy rather than traditional munitions. The benefits include near-instantaneous targeting, low operating costs per shot, and an effectively unlimited magazine as long as sufficient electrical power and cooling are available. These qualities make laser weapons well-suited for modern U.S. defense priorities, which emphasize precision, efficiency, and sustained presence without heavy logistical demand. General Atomics has spent years developing compact and reliable laser systems through its electromagnetic systems division. The focus has been on improving the stability of the laser beam, minimizing size and weight, and increasing power density to make the technology practical for aircraft applications. The Avenger's size and jet propulsion make it one of the few unmanned platforms capable of generating the necessary power while maintaining high endurance and speed. Engineers have also been working to manage the heat generated by continuous laser operation through advanced thermal control systems that fit within aerodynamic constraints. The Avenger itself remains a versatile and proven aircraft. Designed to combine stealth features with long endurance and high subsonic speed, it has been used in various U.S. research programs as a testbed for next-generation technologies. It carries internal weapons and sensor bays and can fly autonomously for extended periods. The addition of a laser system would transform it from a primarily surveillance and strike test platform into a multi-role asset capable of precision defense and offensive operations without relying solely on kinetic weapons. This work aligns with broader U.S. Air Force and industry efforts to create an ecosystem of highly autonomous combat aircraft. General Atomics' Gambit family of drones represents this shift, a line of modular, AI-driven aircraft that can share components and mission systems across multiple designs. The company's participation in the Air Force's Collaborative Combat Aircraft program further integrates these concepts into official U.S. defense planning. Under this approach, drones such as the Avenger, Gambit, and future CCA variants could operate alongside crewed fighters, extending sensor range, providing protection, and performing independent tasks. The concept of a laser-equipped Avenger fits this vision perfectly. A directed energy weapon can provide real-time response against fast-moving threats, such as small unmanned systems or precision-guided weapons, while also offering the ability to disable or deter targets without visible warning. These capabilities enhance survivability and control on the battlefield while reducing the risk of collateral effects. The United States has prioritized this kind of precision technology to ensure its armed forces maintain a technological and tactical edge. Although General Atomics emphasized that the current rendering is not part of any specific government program, it reflects real progress in combining directed energy with unmanned aviation. The company is investing its own resources in advancing both technologies simultaneously, showing confidence in their future operational value. Engineers and defense planners now see practical timelines emerging where podded or integrated laser systems could begin flight testing within the next several years, leading toward more advanced configurations in the early 2030s. These developments underscore a steady and deliberate path for U.S. defense innovation. The integration of lasers into platforms like the MQ-20 Avenger demonstrates not only technical achievement but also a clear strategic direction. The U.S. defense industry continues to push boundaries in autonomous systems, energy weapons, and data-driven warfare, ensuring that American forces remain equipped with unmatched precision and adaptability. The concept of a laser-armed Avenger may still be in the research phase, but it represents a realistic and near-term vision of where U.S. unmanned combat capabilities are headed, a future where speed, autonomy, and directed energy converge to keep the United States at the forefront of air-powered technology.